Okay. 2.2, ready, set, go. Here's an example. If someone gives you a trinomial expression, a quadratic, 4x squared plus 7x minus 6, well, we always know about this x squared, we always know about this x. There's always some number here. We give them names. The coefficient is 4 on the x squared. So it's like you put in an x, you square it, then you quadruple it. Well, we give that quadrupling a name. It's named a. So a equals 4 here. It's just the number in front of the x squared quantity. The word coefficient means like co-worker. Efficient means to work nicely, to work well. Coefficient means it's working well with this other quantity. Okay, great. How about this coefficient? It's a 7. We call that the B coefficient. We're always using these slang terms, A, B, C. In this one, A is 1, because it's not there. B is negative 7, and C is 3. So we can quickly talk about these numbers. These numbers do matter. Of course, the squaring and the variable amount matters, but the coefficients end up mattering too, so we give them these names. Here, C is 0 because it's not there, but A and B have a value. Any other tricky ones? Yes. One of the terms has no value. One of the letters, A, B, or C, is missing here, so it has a 0 value. Now when you get down here, you're going to have to multiply this out with your rainbows. So multiply, 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 combine like terms, and then report the A, B, and C. This one set up two quantities, two parenthesis groups, and then multiply, 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 and combine like terms, and then multiply in the negative sign. The last thing is the negative sign should come in and flip all the signs. So a lot of multiplying there. A lot of multiplying there, but no little annoying negative sign. A lot of multiplying and combining like terms there. Okay, great. Next page. This is fun. Okay. Graph y equals x squared. You guys have done that. You guys are pros at that. No problem. Okay, this is interesting. That is a lowercase Greek letter omega. And it's just some random symbol they chose to be added to x squared quantity in order to make the graph have two x-intercepts. What are they talking about? Find a value for omega such that the graph will have the specified number of x-intercepts. So we know x squared, well, you will know after you graph it, it's just sitting on the x-axis. What would you have to add to it to get it to drop down so that it has two x-intercepts? You're trying to get it to look like this. So there's an x-intercept over here and an x-intercept over there. What would you have to add to it to make it do that? What would you add to it so that it stays with one x-intercept, just sitting with a vertex on the x-axis? What would you have to add to it to make it have no x-intercepts? And you're just trying to think of, let's see, find a value. So you just need to come up with one instance where if you add something to x squared, it'll make it so it crosses the x-axis twice instead of only once. How do you make it stay at once? And how do you have it have no intercepts? Just a number. What do you think? Now these ones are upside down. So it's going to change all the answers. In order for it to have two x-intercepts now, it's an upside down parabola. How are you going to get it to have two x-intercepts? Figure out a number. Any number. Okay, you guys should be able to graph those and graph those. Oh yeah, good times. Good times were had by all. AOS means axis of symmetry. Okay, this video's 5 minutes long, so this would be enough. There's my kitchen.